Hey everyone, we have a video here showing you one last time how we can use the definition of slope and combine that with our understanding of limits to give us the proper mathematical definition of a derivative. All right, so we have some imagined curve here and we want to find the derivative at this point, at point A comma f of A. And the derivative is that instantaneous rate of change. So if I were to zoom in on this and keep zooming in on it, it would get flatter and flatter and flatter until it looks something like a straight line. It's called local linearity. Well, that straight line is just the tangent line. And I want to find the slope of that tangent line. That's my derivative value. Well, I do that by saying, well, let's allow this point up here to be a floating point, and we can find the slope of a secant line with our simple definition of a slope. But then I allow mathematically that point to float closer and closer and closer and closer to the fixed point, and that's our limit. And so, like I said, taking this simple definition of a slope and writing it in limit form will give us a derivative. So I'm going to say mathematically, let's let the limit as our floating point x gets closer and closer and closer to a. Well, that's just going to be, and when you go to try to remember this, I find the easiest thing is to remember that in math, we usually write the variable first, and then there's the number after that. So my difference from x to a is going to be x minus a. That's how I find the change in the x values. My change in the y values will then just be f of x minus f of a. So if you start down here, you'll get the order correct, and then you can mimic that up there because you know that the same points should be above and below each other. Y2 and x2 are above and below each other, okay? So hopefully that helps. Once you do that, you've got the definition of your limit set up. We can now apply that down here to this example, okay? So this shape it's just a parabola. I think it goes something like this, and we're finding the slope over here. When I plug in 2 for x, 2 squared is 4, that's 8. 8 minus 6 is 2, plus 1 is 3. So that's 2 comma 3 right there. That's my fixed point. So I write the limit then as x gets closer and closer and closer to that fixed value a, which is 2. And that's going to be then in the slope formula. It's going to be f of x is just this function. I just write that down there. 2x squared minus 3x plus 1, and then minus, well, what's f of a? That's my value I just found, 3. And that's all over x minus a, which is 2. All right, so this is the limit that I need to find. Now, if you just plug in 2, by definition, we know that it's going to be 3 minus 3 over 2 minus 2, and that's 0 over 0. So we need to do some algebra magic to it. That's what you guys have been practicing. I combine these, all right, and then I'm going to factor. So I say this is equal to then the limit as x goes to 2 of 2x squared minus 3x and then minus 2. And that's all over x minus 2. Now I know that this is going to factor with this as one of the factors. So it's really easy to just set that up, x minus 2 over x minus 2. We know these are going to cancel. So what will that need to be? Well, it's got to be 2x to give me 2x squared, and it's got to be plus 1 to give me plus 1 times negative 2 to give me 2. So you can fill in each of these in a quadratic by knowing what my first and my last terms will be. You can also just factor it old school, or you can do polynomial long division, which is exactly what you do if this is to the third or the fourth or the fifth power. That's why we've learned polynomial long division. Well, these cancel, and so this is just the limit as x goes to 2 of 2x plus 1. When I plug in 2 there, I get 5. And that's my limit value. So the slope of that line is going to be, have a slope of 5. And if I wanted to, I could find the equation of the line by just plugging in that point with that slope and getting the point slope form of that line. Okay, moving on to the next one here. This is a root function, so this is going to look something like that. And if I plug in 2, I get 4 plus 1. Oops, that's not very convenient. Let's make this be 4x plus 1. Okay, if I plug in 2 there, I get 8, and then plus 1 is 9, and I can take the square root, and that'll give me 2 comma 3 again. So I got the same point, but an entirely different function. In this case, we're expecting that to be a positive slope, maybe not very steep. We'll see what it is. Again, I set it up. The limit as x approaches 2 again of our function, the square root of 4x plus 1, and then minus, in this case again it's 3, all over x minus 2. Again, of course, if I plug in 2, I'm going to get 3 minus 3, which is 0 over 0. That doesn't work. I know again, I can do some algebra magic. In this case, the trick is to multiply by the number 1, something over itself. In this case, with the radical, that's the trick, the tip-off to do radical plus 3 and radical plus 3. It's this exact same thing under the radical. I don't even write it. You can do it. That's my own shortcut. You won't see that in textbooks, but I give you permission to do that. Well, what's that going to be? Well, when we FOIL this out, the radical goes away. I still have the limit as x goes to 2, but now when the radical goes away, I get 4x plus 1. The rainbow bits, the middle and the outer, they're always going to cancel. It's going to be exactly the same thing. 3 times the radical with a minus and 3 times the radical with a plus. They cancel. Then I just get 3 times 3 with a negative and a positive. It's always going to be minus, and then whatever that last thing is squared, in this case 9. Then that's over x minus 2 and the radical plus 3. Again, I'm just saving myself a little bit of time. I'm not going to write that out. This I can simplify. That's 4x minus 8, okay? Well, 4x minus 8, I can factor out of 4, and I'm going to have 4 times x minus 2. So I'll write that down here. The limit as x goes to 2 of 4 times x minus 2 all over x minus 2. Now here's where I'll write it again. The radical is then 4x plus 1 and then plus 3. And that's all in the denominator. Now this cancels and this cancels. And I no longer have the problem with 0 over 0 because when I plug in 2 right here, I get 3 plus 3 and I get 6. And there's nothing to plug in up here, that's 4. So it's 4 over 6, which is 2/3. That is the slope of my tangent line. This line over here would have a slope of up 2 and over 3. Again, I could put that into my point slope form if I wanted the equation of the line, but I'm going to move on to the next one. So this last example is a fraction type. Again, if I plug in 1 squared is 1, 1 minus 4 is negative 3. I get negative 1 as my point, all right? So same dealio here. I write the limit as x goes to my fixed value, 1. My fraction then is just this function right here, 3 over x squared minus 4, then minus a minus 1, all over x minus 1. That's this one here, all right? These fractions, what I'm going to do is just get a common denominator. So I'm going to say this is equal to then the limit as x goes to 1, and I write 3 over x squared minus 1, and then that's a plus 1, minus 4. Minus a minus 1 is plus 1, and I need a common denominator. So I need something over itself with the common denominator here. So I just write x squared minus 4, x squared minus 4. If this had not been plus or minus 1, if it had been something else, I would have cross-multiplied to get a common denominator. So this is where you need good fraction adding and subtracting skills. But finding a common denominator is something that you guys should be familiar with. Now I can just draw one long fraction bar and eliminate this. And my numerator now is 3 plus x squared minus 4. 3 minus 4 is negative 1. So this becomes the limit as x goes to 1 of x squared minus 1 all over x squared minus 4, times x minus 1. All right, I just reversed the order. Well, this factors. This will always factor and will cancel with your denominator. So you should go looking for it. In this case, this factors to x minus 1 times x plus 1. All right, so now I can cancel this and this. And what's left is the numerator and the denominator. So this equals the limit as x goes to 1 of x plus 1 all over x squared minus 4. Now I can sub in 1 plus 1 is 2. And when I plug in 1 and I subtract 4, I get minus 3. So my slope then is negative 2/3. All right. All of these examples have used the x go to a method. All right. You could repeat all of these with the limit as h goes to 0. And what you're doing is you're putting it over h, and then you're doing f of a plus h, your fixed number plus h, minus then f of a. Okay, so it's similar. Mathematically, it's identical, but algebraically, it's slightly different. And you can try all three of those that way. Good luck.